10 points. Good morning, e-learners. And unlike yesterday, it worked the first time. Okay, so looking at the calendar, we're going to do an algebra review today. It's listed on, if you flip the next page from the homework, it says Algebra Review, Linear Equations. The book, for two reasons. One, it doesn't want you to forget the algebra skills you learned last year. And then two, right before it uses these skills in geometry, it reviews those skills. We're not going to review all of Algebra 1, just a few things. So technically, and for my honors class, I don't even do this. I just say, get started on your homework. Right? If you're in an honors geometry class, you know how to do algebra. For this class, you know how to do algebra as well too, but I'm going to give you a quick mini lesson. This is a straight up review. How many people are confident? I know Mike is. How many people are confident they can solve equations? All right? So this is just a quick review. Quick review. You guys were solving all kinds of crazy equations all of last year. So your homework, write this down. Usually I give you a sheet of paper, but not today. It's 2 through 46 evens. Guess what the honors get? I get them all. They're going to be doing 46 problems, which is why I don't teach them anything. I just say get started on your homework. But you guys, I just need you to do the evens. There'll be plenty of practice. Hey, that's a lot of work too. That's what, 23 problems? It starts as easy as a two-step equation and eventually it works up to multiple step equations. There's only a few with fractions, not many. I don't think there's any with decimals. Confirm that? Are there any with decimals? No. Okay, none of them have decimals. Okay. For those of you that had me, right, in Algebra 1, which none of you did. Oh, duh. So now you had me in pre-algebra. I taught you how to do algebra problems, whether they're one step, two step, or multiple steps. So this is a quick review of your algebra skills. When you solve equations, right, here's an equation. We're trying to find the value for x that makes the equation true. In other words, the left side equals the right side. What's the answer? X equals 5, right? So x equals 5. These equations come in different flavors. These are called one-step equations. Why? There's only one step. Karis, what number do I need to get rid of? Get x by itself. How's 4 attached to x? How do we get rid of division? Multiply both sides by 4 and you're done. Okay? Also, by the time we get to geometry, it's not that we skip steps. It's that we don't need to show the steps because we all know how to do algebra. What's the answer? X equals 5. What's the answer? We don't need to write that, times 4 across that last step of a one-step equation. We don't need to write that. We all know what to do by the time you get to geometry. Pre-algebra, you write that step, and even in Algebra 1, you write that step. But in geometry, bless you. But in geometry, we're okay with skipping the last step, but we're not really skipping it. It's just that we know what to do. You divide both sides by 2. You multiply both sides by 4. There are other ones where you're not going to want to skip the step, like this one right here. There might be a few of you that could do this in your head. Anybody? Can you do this in your head? Most of you can't. So this is the one that you want to actually do this step. These two, you can do this in your head. Okay? By the way, what's the answer? 15, right? Yeah. So clearly, right, there's at least one of us that can do it in their head, right? But most of us would probably have to write, what are we going to multiply both sides by? 3 over 2, right? You take whatever's attached to x, if it's a fraction, you flip it. And that's what you multiply both sides by. You multiply this by 3 over 2, everything cancels. And then you got to see what that equals. Okay, we will do that one. Two-step equations, yeah. If they're easy like this, maybe you could do that in your head. By the way, that's going to be a decimal answer. Okay. But, okay, let's show our work, right? Is that right? Is it 2.5 or is it 3.5? No, it's 7.5, isn't it? Yeah, 7.5. Okay. Okay, now we come to, we need to actually do some work, right? We really need to do some work, and we really need to do some work, okay? None of you, is there one more? Oh, that's it. None of you should be asking me, how do I do this, right? I mean, granted, that's a lot of steps there, but you guys know how to do this. All I'm going to do is refresh your memory. For those of you that like, yeah, I really remember how to do that. Yeah, these are exactly like what's on homework. It starts off like this, and it ends like this. This is maybe even number 46. Yeah, 46 has got variables on both sides and really big numbers, and it's ugly, right? Okay, so the main idea, if you remember, I call these the 3 key ideas in algebra. Let's see if you remember from 2 years ago. The 3 key ideas in algebra is, how do you know you're done? How do you know you're done with algebra? And a number, right? In other words, you're done when it says x equals some number, right? You keep working at this thing called algebra until the variable is by itself. It could be the left side or the right side, doesn't make a difference. But what's on the other side is a number, okay? We say, in formal math speak, we say you need to isolate the variable. That's just big fancy words for get the variable by itself. So we keep working until the variable is by itself. That's key idea number 1. Whatever you do to one side, you got to do to the other side. That's the key. That's the balancing thing. I'm sorry. By the way, there could be multiple steps involved, but eventually you get down to the final answer. Okay. To get rid of something, we do the inverse. How do you get rid of addition? How do you get rid of multiplication? How do you get rid of squaring? Get rid of squaring from last year. Yeah, remember I didn't teach you that in pre-algebra. That's an algebra 1 skill. Okay? No, you're not going to be doing any square root today. We will this year, but not today. So the 4 inverses are addition, subtraction, multiplication, division, and vice versa. And then whatever you do to one side, you must do to the other side. This is generally if you get something wrong, what you've done, other than a common math mistake. Okay? Remember, if you decide to multiply one side by 4, you got to multiply everything on the other side by 4. Everything. Not just one thing, but everything. That's why we typically get rid of addition, subtraction first, so that you're not multiplying 10 things times 4. Clearly, my animation is way out of order here. Okay? So what am I going to do to both sides here, first step? Subtract 5. I'm not going to just subtract 5 from the left side. I'm going to subtract 5 from both sides. Okay? All right. So just some guidance. We're going to be done in about 10 minutes max. Some quick guidance. Quick guidance. All right. If you need to show the work, when you decide to divide both sides, I got to divide everything by 2. So we draw a fraction bar for division. We write it 2. What happens on the left side here? These cancel. That big slash means cancel, but what does it really mean? What does that big red line really mean? Does it mean 0? 1. It means 1. That's just a big number 1, right? This is just literally the number 1. What's 1 times x? Okay, that's what it means mathematically. We all know that what does it mean in practice? It just means everything goes away, right? But I'll have kids to say, well, it doesn't mean 0, it means 1. 1 times x. 10 divided by 2 is 5. Okay? Exactly. You would get a nonsensical answer. All right. We said this before. How do you get rid of division? Kara said we multiply. So this one's careful. We don't want to write times 4 down here. That would be really times 1/4, right? So when we write that, we're really multiplying by 4. Well, to multiply fractions, you need another fraction. Yes, this is visually how it's supposed to be done. The 4's cancel, right? But I'm going to multiply both sides by 4. The 4's cancel. That's a 1. 1 divided by 1 is? And 1 times x is? Okay, that's math. What really happens here? Everything goes away, and you're left with x. But the idea is this big red line is the number 1. 4 times 10 is 40. Okay? So those are the easy one-steppers. This is the one that I generally will see kids forget. If you have a last step, remember? If you have a fraction, if it's a mixed number, you need to change it to an improper fraction. We can't multiply by mixed numbers. We can only multiply by improper fractions or proper. If you're left with a fraction attached to a variable, you take that fraction and you flip it, and that's what you multiply both sides by. Why? Because this, check it out, everything cancels. On this side, 10 is not a fraction. How do you make 10 into a fraction? 10 over 1, and we said we're multiplying by 3 over 2. So this is why Wes was in his head. Wes did this. 10 times 3 is, and 30 divided by 2 is pretty good, right? Okay? Review. Like this should, I'm not teaching this to anyone. We're just reviewing. Okay, Chris, what were you told when you have variables on both sides? Which one do you want to always move? The big one or the small one? The small one. Why? You remember? Oh, well, first off, could you move the big one? You certainly, whatever you do one side, you do the other side. But Chris was right. We want to move the small one. Who knows why? You had me. I know I said it. What do you think, Connor? Why do we want to move the small one? Millie? What do you got? No one wants to mess with negative numbers, right? That's the one you're probably going to screw up. That's why we always move the small. If you move the smaller of the two, I'm not saying the answer won't be negative. You just deal with fewer negative numbers. So we subtract 2x from both sides, right? So we always move the smaller. We're left with a positive, and my life is a little bit easier, right? Subtract 2x from both sides. There. Hey, how many steps did I skip here? 4? How many steps did I skip right there? Just 1. Which one did I skip? Why? Because, come on, right? 2x equals 10. We know the answer is x equals 5. You are allowed to do that from now on through calculus, whatever you take. Nobody actually writes divide both sides by 2. They just say, oh, yeah, what you get right here, we understand. But I would not skip that step. Okay. What property are we using here? Who said that, Karis? What happened to you? You were not the same girl that I had in pre-algebra. All right. Absolutely 100%. That's the distributive property. So in general terms, either side, and by the way, tonight for homework, you're going to have it on both sides. If you ever see the distributive property, always do that first. Okay? What do we get? We do the distributive property here. Where will you make your mistake with the distributive property? 2 mistakes I generally see. What 2 mistakes do you generally see with distributive property? Negatives, absolutely 100%, especially when it's, sorry, you learners can't see this, especially when it's like that, you're distributing a -4 to the inside. The other mistake is you'll be so happy that, oh, it's distributive property, you'll forget to multiply the 4 times the -1. I'll see that occasionally. So if there's a distributive property, do it first. What are we doing now? 4 to both sides.
And then skip that step.
Notice now I skipped 2 steps. Right? Technically, I didn't skip the step. I just didn't write what I was doing. Right? I didn't skip a step. Right? I did the distributive property. Then I added 4 to both sides, and I wrote the answer. I didn't really skip the step. I just didn't show my work. This is also allowed from now on. Okay? You're big kids, big math kids now. All right. Oh, dear Lord, look at that sucker. Holy cow. So what are we going to do first, Jenna? Distributive property. What do you get? Oh, it's the same thing. 4x minus 4. Okay, so if there's distributive property, do it first. Then the next step is, if you need to, combine like terms. Is there anything to combine on the right side? What? On the right side. Is there anything to combine?
Everything.
Is there anything to combine on the right side? Is there anything to combine on the left side? What? Well, that's the answer, but the x and the 4x, right? So you combine those and you get 5x. Now, you guys need to stop me if you're like, you lost me about 10 minutes ago. Most of us, and I can tell, you're like, come on, when is this going to end? I already know what to do here, right? Okay. Variables on both sides. Some math teachers, I'm not one of them, will tell you to move the 19 to the 4 first. Why don't I like that? Well, if you don't know which side your x is going to wind up on, you just may have given yourself extra work. When you get it down to addition, subtraction, and you have x's on both sides, move that variable first. I got rid of all the distributive property. I got rid of all combined like terms. Now get your x's on one side. That way, you don't have to, oh, I moved the variable to, or these are called constants. I moved the constants to the other side. Here's which one we moving? Okay, so move it. What do you get? Okay, how do we get rid of 2x? Is it positive or negative 2x? Positive or negative 2x? How do we get rid of positive 2x? How do we get rid of positive 2x? We subtract 2x from both sides. So that's going to give me 3x. And then it's a two-stepper. You can take it from there. Ooh, ugly. Positive and negative numbers. Who can do that in their head? What's the answer? In your head is.
Oh, now I'm. Don't you love it when you're in front of class?
Oh, by the way, this is not required. You do not need to know how to do this in your head. I'm just seeing. Can you do this in your head? What do you got? 5? Wes?
What?
He said 5. Yay or nay?
Negative.
Oh, now he's saying negative 5. Micah? He's saying negative 5. Okay, so have I kind of made it clear that maybe you might not want to do the whole thing in your head? Last step, okay, sure, as long as there's no fractions. But even a two-stepper, chances are you might want to show your work. Add 4x to both sides, what do you get? Oh, sorry, add 4 to both sides, sorry. Therefore, the answer is. Now, no one makes the mistake, right? Why? Because you visually can see it. Before, you're trying to do 2 steps in your head. Okay, every single person guessed wrong at first. Eventually, we got a couple people that get it right, but that was after they made the initial mistake. So I'm just saying, be careful if you're trying to do a bunch of steps in your head. You can certainly get it wrong. Okay? All right. There's a big but there, right? What can happen if we have variables on both sides? Do you remember? Okay, well, I had variables on both sides, nothing happened. I got to an answer. But what can happen? I can occasionally, doesn't happen all the time, subtract the variable and poof, the variables go away. There's 2 options or 2 things that can happen. You either get as an answer as, do you remember? Anybody? All real numbers or somebody? Or no solutions, right? Let's take a look at that. Okay, so this only happened, it will happen tonight for homework, right? Be ready for no solutions, right? The symbol for no solutions, for those who don't want to write no solutions, what's the symbol? Right, a 0 with a slash through it. That means no solution. It's the symbol null, N-U-L, set. That means the set of all answers is empty. When we say the empty set, null, empty. And then infinite solutions you can write, or all real numbers, or you can literally write the infinity symbol. Okay? All right, let's do this one. Distributive property. Boy, I'm not very creative today. I'm using the same one each and every time. Now what? Subtract what from both sides? 4x. That leaves me with negative 4 equals 6. In what universe does negative 4 equal 6? And, well, hopefully not Mars, right? No universe does negative 4 equal 6. Therefore, what's the answer? No solution. So this one's a no solution. You remember this, right, from last year, Chris? Yes? Right? Hey, this is not Chris, there's some other people as well, too. Remember geometry. You got to have your brain turned on, right? If you're distracted, it better be because I've already finished my homework and I know what I'm doing, right? But if you can't concentrate for 15 or 20 minutes, geometry is going to be a butt kicker. We're not doing the hard stuff. We're just doing a review right now. What was the other possible answer? Not for this one. Let's see what that looks like. So this is what infinite solutions look like. Same problem, right? 4x minus 1, 4, sorry. Subtract 4x from both sides, and we get, if the variables go away and you're left with a true equation, infinite solutions, right? Occasionally I will see kids do this. Occasionally I will see kids do this. Yes, I realize that's wrong. right? Occasionally, maybe not geometry algebra 1, but I'll see 4x minus 3x. And for some reason, kids think that it's 0x. I don't know why they do that, right? Not sure why that happens, but occasionally I see that. Just remember, 4x minus 4x is not 1x, right? It's 0x, which 0 times x is 0. Okay? Okay, we okay? And that's it. All right, Michael, what number are you on? 42. Holy cow, he's already on 42. So clearly, this must take, when did I start class? I don't know, but he's done with his homework, right? So it's not that it's that long of homework, unless you skipped around. Okay, there's your homework. I'm going to be walking around giving you help, right? You may work with a partner if, finish the sentence. I'll say if you're really working, right? If you're talking about the problem, wait, no, you add 4 to both sides, I don't have a problem. Usually when people are working together, sometimes that devolves into not talking about the math, talking about other things. So absolutely, if you want to work with somebody or check your answers, give somebody, do that. Yeah. Yeah. Go for it. All right, any questions? All right, e-learners, that's going to do it for today. If you have any questions, send me an email.
Taking screenshots.